And hey, we want to respect everybody's time. It is 11 a.m. Let me turn it over to Mike Masters, our SVP of Sales and Marketing, to get things going. And again, thank you everybody for joining today.
Todd, thanks. And thank you everybody for coming. I want to welcome you to this Generative AI webinar for manufacturing. So we know that there's a wide distribution of attendees on where you are on your GenAI journey. So we wanted to make sure we kept this at a relatively high level. But if you'll look on the right side, you'll see there's a Q&A box on your toolbar for this webinar. You can click in there and ask questions all the way through, and we'll do our best to get to answers at the end. And anything that we don't get to, we will follow up afterwards and send answers. So I think that one of the, again, keeping it kind of at a high level, we're gonna walk through kind of why GenAI is important, really what's different about it, and then kind of go into like really how are manufacturers starting to adopt it, and then get in there and answer kind of questions that you have on the back end. So we're gonna try to make this a little bit interactive. So we're going to open up with a couple poll questions and kind of go from there. So if you see on the right side, you'll see a little chat bar that has a bar graph inside. If you just click on there, you'll be able to answer the poll questions. So this is really like how many of you are really thinking about AI or you've adopted AI, in anywhere on the spectrum from we're becoming a lights out manufacturer, AI is all the way through our manufacturing to we're just kind of getting started on our journey, or we're just talking about it right now. I mean, I think people are all across the spectrum right now in manufacturing, just to get a little idea. So I'll give everyone a couple seconds to answer their poll. I think we can move on to the next question. So now the question is, now beyond AI, how many of you have started to adopt generative AI, either in your current, solution, like you're building something custom, or you've adopted a outside solution that incorporates generative AI in it, or now you're really just trying to figuring out like how is it going to impact me as a business? What can I do to enable my workforce to be more productive, leveraging generative AI? And wherever you are and like where you are on that journey to AI and generative AI adoption. I'll give you a couple seconds to answer the question. You can kind of see where the rest of the organizations are and relative to where. I think in general what we've seen is there has been a lot of adoption in AI, at least on the early stages. Within manufacturing, generative AI is still newer, and so it's still more of a conversation topic, but there are definitely customers of ours that are actively working on custom generative AI solutions for their businesses. So I think maybe we close down the poll and we turn it over to our lead data scientist, Tim, who is going to give you an overview of really what is generative AI and why is it important. What's different about it? So Tim?
Yeah, thanks, Mike. So yeah, I'm here to answer the question, what is generative AI? And more so like, why now? So AI has been around for a long time, right? We just had those couple polls. I can see the answers. Some of you are already implementing AI solutions, but now when we ask about Gen AI, a lot less of you are already implementing Gen AI solutions. So we're going to go to the next slide. When you kind of talk about, everyone's probably seen this recently. My graph on the top right shows AI performance in a lot of tasks like speech recognition, image recognition, language understanding, all that type of stuff. Just in the past couple of years, these AI models have really skyrocketed in performance and even passed human benchmarks with these models. And at its core, this is coming from this generative AI revolution. So again, just want to answer what is generative AI and how is it different than what we had in the past? So on the bottom left, you can kind of see there's two main types of AI models. There's discriminative models and there are generative models. So a discriminative model basically is going to learn like a decision boundary, that it can classify different data points from one class to another, or it can do regression calculations, things like that. While a generative model will calculate a probability distribution of the data. So what's really interesting is a generative model can still do discriminative tasks. So you can still, based on probabilities, define things as one class or another. The really cool thing is you can kind of go in the reverse direction and you can create random examples that are representative of real input data with this generative model. So I like to think of generative models as a two-way street, while discriminative models are more of a one-way street. But as I mentioned, neural networks, AI has been around for a long time. So what has changed recently compared to what we've had in the past? As you can see, in 1950s was when we first had our first artificial neural network, the Mark I perceptron. And this graph is probably similar to things that you might have seen in the past, where you kind of have your input on the left, hidden layer of calculations in the middle, and some output on the right that is trying to predict what you are looking for. If we go to the next slide, again, that graph is simplified on the left, but the multilayer perceptrons were kind of our early AI models, where you basically just add in a lot of layers for computation. It's really just a generic computation mechanic. Over time, though, as we wanted to solve more and more complex problems, we had to kind of diverge our solutions per use case, and we had to add in what we call inductive biases to the models. So an inductive bias is basically a rule that you add to the model to try to approximate human intuition. So for things like language models, so long short-term memory models, we added in rules that basically said, read the words from left to right, just like we do as humans, and try to gather understanding as you read from left to right. Similarly, for vision models, convolutional neural networks, we would add in rules about thinking about the most important thing to a pixel is going to be the pixels directly surrounding it. So we're adding in rules that talk about the spatial nature of vision or the sequential nature of language. And over time, these solutions kind of diverged in how we're adding these rules to things. We needed to add these rules basically because we just didn't have a ton of data for these models to learn these things themselves. But if you fast forward now to the next slide and to more recent history, there's been a convergence of these solutions back down into a more generic computation mechanic. This has been because of kind of a triple whammy of things that have happened pretty recently. The first is going to be the huge explosion of data coming from the internet. So people writing things on Reddit or Twitter, whatever forum boards, and then posting pictures to Facebook, Instagram, whatever. There's just a huge amount of data available to researchers now to mess around with and try to train models on. Additionally, past decade or so, our hardware for computing has really grown in efficiency with GPUs and TPUs that are really able to process a lot of data a lot more quickly. Then finally, in 2017, Google released a paper. The title was "Attention is All You Need," and it was introducing this brand new neural network model architecture called the transformer. The transformer is able to take advantage of this huge increase of data and our way more powerful hardware through its use of what we call the self-attention network. So really the main point of these transformers, we've kind of converged on solutions. Again, for a middle period there, we were having separate models for every different use case. Now we're kind of converging down to this transformer model, which has a lot of capabilities like parallel processing, so it can take advantage of this nice hardware, and then at the same time, this self-attention network. But before we move on, I'll just point to this kind of graph I drew on the bottom right where AI performance is in blue. It's been increasing over time, but there's been a switch in importance from us thinking of more and more clever rules for our neural networks. And actually now we can kind of take those rules away, remove the limitations when you add in guardrails, and just add in more and more data. Let these models learn the rules for themselves and kind of think of them better than we could think of in a laboratory ourselves. So if we go to the next slide, I'll talk about this self-attention network, which is really the core of the capabilities in these generative models. So as I mentioned, in the past, a lot of language models read things sequentially, one word, then the next word, and then tried to predict things from that and tried to gain understanding in that way. So you can see this example in the top middle in the red, trying to translate a German sentence to English. If you were to do that sequentially with a very simple, naive model, you'd get something nonsensical like, can you me help this sentence to translate? Self-attention fixes that where the model can look wherever it wants in the input data at any given time to understand the context and generate the appropriate output. So the green sentence below, can you help me to translate this sentence? You can see the crisscrossing of arrows in this translation. You can see this model thinking and placing things where it needs to because it learns, it has its own ability to attend itself to where it needs to. So this is obviously a very short sentence, but these models have very large context windows where if you were to think of a paragraph like 20 sentences long, it starts with the word he, talks about him doing something, and then maybe in the last sentence it refers to Tim talking during a webinar. Sequential models couldn't handle understanding what that pronoun he, who they were referring to, both because of the misordering of pronoun to an entity, as well as the really long context window. It just can't keep track of things for that long. Transformer model, with its self-attention network that can look anywhere at any time and process the data in parallel, can very easily, with that massive context window, understand that he is referring to Tim, even though it's not revealed until 20 sentences later that it's me. The even more interesting part about this is that this same model architecture that can understand sentences in this way can also understand images and lots of other things in this way. So to look at an image, we basically patch things up, take the image, break it up into a bunch of little chunks. You can think of those little chunks as words and the whole image as a paragraph. And now we're at the same problem. We just use the same model architecture where the model can look at the different chunks as needed and understand what's going on in the image. Say there's a parrot sitting on a limb, as you can see on the bottom middle. So all this culminates into, I think this is a great example on the right where someone inputs two things. They ask a question and they input an image to one of these transformer models, so GPT-4 specifically. They ask, what is funny about this image? And then there's obviously this image of a phone with a large cable plugged into it. The model is able to understand the question and understand what's going on in the image and respond and say, that's an iPhone. You should be using a lightning cable, not a VGA cable. That's way too old of a cable and it's way too big. That just won't work. So that's just one example of these models handling a few different use cases. But if you go on to the next slide, really the important thing is this evolution of these transformer models has really taken off in the past few months with lots of both open source and enterprise developers making accessible these foundation models that can do things like code completion, image segmentation, translation, arithmetic, all these different types of things, again, with the same core model architecture to tackle these things. This brings about some really cool emergent capabilities of, in the past, we've needed a lot of data very specific to a task to train on for a very specific model to deploy that model. Now we can do things like few shot and zero shot learning. And I'll leave it to Jason to explain that while he talks about more use cases for manufacturing with GenAI. Before that, we have a couple poll questions that I'll let Mike walk us through.
Thank you. I think the next poll question is just, when are you planning on, for all those that have said it's on the roadmap or thinking about it, when are you planning on implementing a GenAI strategy for your business? What are you thinking from a timeline? And I think, people are obviously going to be all over the spectrum on this. And as you learn, hopefully on the backside of this, you'll be like, hey, we were thinking no plans yet, but now we're thinking 0 to 6 months because it's going to be that important. We'll give everybody a couple more seconds to answer the poll question. I think we can kind of move on. And if you are exploring, for those that have it on their roadmap, what GenAI platform are you exploring? Are you looking at working with Azure or Microsoft and OpenAI? Are you looking at working with AWS? Are you looking at working with Google? Or are you, is it, you're bringing in, developing your own, leveraging things that are being developed in Meta or other startups and companies that are developing their own large language and training their own large language models right now? Most are exploring with Amazon, Google, or Microsoft / OpenAI. But it'd be interesting to see where everyone is on this. I think that's not, well, what we're seeing in the poll results isn't dramatically different than what we're seeing in the market. I mean, when we are a Google launch partner for Enterprise GenAI, and when we first were out talking to customers about Google relative to some of our work that we were doing with Microsoft and OpenAI, I mean, people had been exploring some of the Microsoft and OpenAI right off the bat because Microsoft was out there faster, but we've really seen a lot of uptake in customers exploring both platforms, and also, Amazon has now launched a few, and so there's also some customers that are exploring on AWS. I think we can shut that down and maybe turn it over to Jason, who is our lead product manager in GenAI.
All right, thanks, Mike. Yeah, thanks, Tim and Mike, for giving an explanation on what is GenAI, why is everyone talking about it right now. So I do want to move on a little bit and just talk about, how might we adopt this in manufacturing. So the first thing I want to just kind of talk through real quick, like what's kind of unique about interacting with a GenAI model versus maybe what you've seen in the past. So on the top here, a traditional machine learning process. This is where you will be working with the data science team to make a model, typically for a specific use case. They're going to have to do a lot of effort up front around gathering the data, cleaning and labeling that data. That data science team will actually go through the process of training that model before you can do anything like providing input to get a prediction. So generative AI models, it's a little bit different in terms of how data science teams might interact with them. So we've kind of mentioned, these large platforms offering these GenAI services. These are truly large language models. They're often built on very large data sets, as Tim kind of noted. And typically you'll be interacting with some kind of foundation model that you're building on a system on top of. So on the generative AI model process, your foundation model provider, they're going to put a big investment into making this large language model. They're going to put it out to the market, and from there you can access that model. And then instead of training, and there are some models where you can do some fine tuning on the training, but in general, this gets more into prompting the model. And typically you'll have your kind of main input question, but you'll also want to bring along extra context when you interact with that model to give context to that question you're asking, so the large language model can kind of tailor the response for your use case. All right, so let's move on. So what are GenAI models good at? One of the really interesting things going on right now, you'll see is, as Tim noted, the two-way street. Generating net new content is something pretty unique to GenAI models. And again, they're built on these massive training sets. Large language models focused on text are getting a lot of the attention, but you may have seen some text-to-image models as well, and really any type of data these models can be trained upon. The second thing to note, the broad range of capabilities. So this is kind of unique, where a lot of AI models that we've typically worked with are for a very specific use case. These models are good at kind of emergent behavior of finding connections between things that we don't purposefully train it to do. So they're very good at kind of generic tasks. And then lastly, just to note, we can tailor these models despite them being fairly broad in terms of their use. There are some methods you can look at for tailoring it to your use case. So let's dig into a few of those use cases. If we could go to the next slide. So the first one we want to look at, which you'll probably see a lot of, is making large and complex data sets easier to understand. Surely any large enterprise is going to have this use case of needing better knowledge management tools. So you may have had experience with a lessons learned log. Say it's like 1,000 rows long when you're trying to solve some type of problem, be that in manufacturing or engineering design. And so what these chatbots can be really good at in these models is actually incorporating a lot of those documents for your use case, so you can very easily ask a question. Another element or another option that you could look into would be a maintenance virtual assistant. And so what you can do is actually tune a model on your maintenance use case with like your systems on the shop floor, and to say like, hey, when this piece of equipment fails, what is a typical use case, or what is a typical repair? What are the typical faults that we find? And you can actually tailor based on your maintenance data set to give you very tailored responses in a very conversational manner on what to do. So on the right there, I just have a quick example. This is from a demo that we built using a Google model. And I'm just asking, what are some common use cases of pump, some common causes of pump failures, and what repairs are recommended? So this use case is actually just producing a net result based on the massive data set. You can find it on the internet, but we could tailor this model to your use case with custom documents and data sources from your maintenance systems. All right, let's look at another set of use cases, content generation. So, you can think about text to image type use cases. is being very popular, or draft this email. But something that you may start seeing more of are things like automating the creation of metrics dashboards. So a lot of BI tools are looking at this at the moment. So this could be, instead of going to your business intelligence team saying, please build me this report, these are my requirements, come back 3 or 4 months later to see your dashboard, you can actually just put that into the chat, and instantaneously at the click of the button, and it will produce a dashboard like this for you. Another area that we'll probably see a lot more use of generative AI models, and this is probably a lower technology readiness level at this point, but the field of generative design for engineering of new parts. So we'll probably see a lot of use in GenAI for generating part variations based on some type of text requirement. And some other interesting use cases, noting that these large language models are very good at working with code bases. If you are a systems engineer working with something like SysML models, a lot of folks are trying to standardize from just a Word doc or PDF-based requirement doc for, say, building some type of engineering part, to put that into more of a SysML, systems diagram. And so you could use something like a GenAI model to actually standardize going from your text-based freeform requirements documents to something more standardized that can be integrated into your digital systems. All right, and then lastly, just wanted to cover one more use case, and this is a very common one, automation. And I guess the specific use case is kind of unique. It's something that we are looking at and investigating within ClearObject, but looking at what is our process for building new vision AI models. So just to note, one part of the process today of making a new vision AI model that can take a long time is just annotating images. So you have to label every single image, maybe have to get hundreds or thousands of images sometimes to build a good model. And someone has to manually go in and draw boxes around these different part defects or objects that you want to identify. So on the right there, you can see this is actually the result of the Segment Anything model from Google, which helps to kind of solve part of this problem of having to spend so much time annotating images. But rather than having to annotate hundreds or thousands of images, what you can do is use few-shot training, which is the idea of just, say, 2 or 3 images annotated via prompts. You could actually produce annotations that are good enough to make a vision AI model. So where before you had to produce 1,000 annotations manually, you can now produce those 1,000 annotations using just 2 or 3 examples with a GenAI model. And then lastly, to note there, virtual assistant support requests. This is something you will see across the board, not just in manufacturing. So both, external use cases of just talking with customers with support requests, but also internally, if you have any support flows, virtual assistants for support requests are another great use case for GenAI models. Okay, so that's a high level, some of the use cases we've seen with talking with some folks around manufacturing where we think GenAI might be used first. And the one question we did want to cover really briefly, a question we get a lot, is just how do we tailor GenAI for your use case? So this is a modified version of that flow I showed before. Before I was showing, this is how you access the generative AI model, this foundation model from the left, and start prompting it and adding that prompt to your question, the context prompt, to get an output. But that was, only trained on that massive data set there on the left. So on the bottom there, you can see your data set. And the question is, how do I get that into the mix here? So how is that integrated? So you really have 2 main options. The first option is to train a tuning layer of that foundation model for your use case. This can be nice in terms of just having everything available from within a single model when you hit a request. The downside of training a model in this way is that whenever you get new data sets, that means you have to retrain that model layer for that data to be incorporated. So what we're seeing a lot of progress with, and what a lot of folks are kind of leaning towards right now, is say every time you produce a new part, it's a serialized part and you want to track some metadata on it, you can actually add that to a referenceable data set using what's called an embeddings process. So if you run into anything like a vector database or embeddings, it's a matching engine approach to kind of smart prompting the model with extra context that's relevant to your use case. And so an example here would be, hey, I just produced part 100, and I want to know something about that part as far as like when is it going to be shipped. I can actually embed that information into a vector database, use a matching algorithm when I ask a question about it to actually match to that index. And then I will get a conversational response from my model as a result. So just wanted to note kind of two approaches there to incorporating your data. Option one, tuning layer model. Train a tuning layer of the model for your use case. Option two, which is really where we're seeing a lot of progress and where most people are leaning, is kind of this embeddings approach where you can use more live data sets to incorporate with your GenAI model. Okay, so that is in a nutshell some of the options you have and where we think you might see some progress in GenAI used in manufacturing. So here I'll hand it over to Mike, who's going to talk a bit more about some of the GenAI platforms that we're seeing is common today.
Yeah, thanks. So I mean, I think Tim did a really great job of kind of covering some of the basics about generative AI, and Jason kind of walked through what's going on in manufacturing and what are some of the key use cases. And I think the reality is you have options. There's the cloud providers. If you're on premise, if you are with Google or Microsoft or AWS right now, if you're with you have instances with all or multiple ones of them. I think you have some options in how you might implement a generative AI, like wherever you are. One of the things that we're recommending with our customers is sometimes when those first builds and some of the custom applications. So in some cases, you're seeing generative AI incorporated into your favorite applications and software that you're using. In other cases, you have particular problems you're looking to solve in your business, and so you're exploring like how can I go and solve that specifically for my business. And so maybe leveraging the capabilities provided by some of these platforms that you see up here to solve that problem and building around that. And I think what we've seen is some of the initial designs and builds have come back, and some of it's looked pretty expensive on how do I solve that problem. So one of the things that we're helping a lot of our customers with is how do we help design solutions that are really going to deliver a big ROI on the back end. And part of that's on the front end. We have helped customers kind of across these different platforms. And one of the things I'd say that we've recommended in a lot of cases is exploring more than one solution to really understand kind of how do you maximize that ROI. It's pretty fast to spin up a proof of concept, across any of these platforms. We're doing that in a 4 to 6 week time frame with our customers to just explore an idea and to get an idea about what that's going to look like, and does it make sense to scale? Am I going to be able to get the return I'm looking for from that? And I think in a lot of cases where you spin up competing platforms, or I should say competing proof of concepts on different platforms to see what that looks like. Who's returning the best results? What's the cost of that solution as I'm hitting a large language model? I mean, there's a cost to that. The larger the language model, the higher the cost is. In some cases, when you tune, as Jason was talking about, how you make your models more efficient, when you tune those models, in your private instance, like that can change the cost, where it can get more expensive. So there's a lot of different options, and so there's a lot of different ways that we can help. We are helping our customers be able to really optimize those solutions so that you're not always hitting the biggest model for every question that you're asking, and then getting a big price tag on the backside of that. So I think that's really the key, is that there are a lot of options, and we do recommend that you explore the different options, and we can help when we're helping our customers do that right now, and we're happy to help others on that exploration journey. I think moving on, just to kind of talk about what our general services are. So, we offer services across a broad range of helping customers, but I'd say in the generative AI standpoint, we are trying. I guess we have customers that are at multiple different stages, not just in manufacturing, although we have, I'd say manufacturing is one of our core industries. We have customers kind of inside and outside of those, but they're different spectrums. In some cases, we're really helping customers with what we call a generative AI discovery workshop. And so in that case, it's kind of it's more of the front end of a generative AI exploration process where we're coming in, one, helping educate the team on what is generative AI, how you can get value out of it, go through the available tools to work through what are some options, but really on the backside, it's helping our customers build the business cases at a high level around the top use cases. Like, what's that going to look like? Like, what is the value we're going to get out of that? And then giving an architecture that we could help build, or you could build yourself, or you can bring in somebody else to build, but give you a high level architecture on how you would actually go and develop a proof of concept around those top use cases. And then, for customers that are maybe already have some use cases identified, or as a follow-on to the generative AI discovery workshop, we're helping customers stand up those proof of concepts. As I said, depending on like what we're doing, but in general, it's a pretty fast process. The tools are pretty good, and there's some really good technology behind that. But we're able to stand up proof of concepts in a 4 to 6 week time frame to really start understanding like what can we actually capture the value that we're targeting in these different use cases. And then based on that, that's our data science and software development support. We can put together product teams to help you then deploy it and scale those solutions. Or again, with the proof of concepts, you're given an architecture on how you would scale that. That's kind of part of that process. And so some teams have their own, they have their own dedicated teams that can scale that themselves. Sometimes they look for outside support, but we help our customers in all those cases. We help train internal teams, kind of across that board. But wherever you are on the generative AI discovery process or journey, we're making sure we can support our customers in that. The other key area for us that we've over the last couple of years we've really been helping customers in manufacturing particularly is around the intersection of computer vision and AI. And now, as Jason talked about, we're bringing generative AI into that to even speed the process. But ultimately, we have multiple customers that are on that journey to become a lights out manufacturer. And so from that, really incorporating vision at the edge with AI and processing and compute at the edge, so that we can really help customers, I guess, improve their quality, improve their output, but use that vision and AI to potentially remove humans from the loop, or arm the humans that are in the loop on their manufacturing processes so they can do their jobs better. And one of the other tools on the backside of that is we offer a visualization platform for those vision AI solutions in your manufacturing process. And so, those are just some of the areas that we offer support in, and we're happy to answer any questions around those areas, or happy to have follow-up conversations if there's anything that we can help you in, be it from a generative AI or vision AI. But we're helping manufacturers across the globe right now in those areas. And obviously the generative AI is newer, but it's obviously really picking up a lot of the efforts that are going on. So I think I don't know, do we have some questions?
We do, but first we have one more poll.
Oh, one more poll. All right.
Please get your questions in the Q&A. There's some good ones already.
So yeah, we were trying to keep this to 30 minutes. We're a little bit over time, but if anybody can stay, they're welcome to ask questions. We'll do our best to answer them. And but thank everybody for your time. And I guess the last question is, as you're thinking about generative AI, what do you think would be your top use case, as you've seen some of the things that Jason sort of walked through? Not surprising, we have an early lead on the complex data analysis. I think that is a really, I think we're going to see that pretty widely adopted in the next year or two. Well, again, I just want to thank everybody for your time. Thank you for joining, and we'll move on to Q&A, and we'll do our best to answer any questions anybody has and any questions that are out there. So I guess I'll turn it over to you, Todd, on whatever questions.
Yeah, thank you, and thanks for putting in these questions, folks. So let's do one of them here is open to anybody really here is, do you consider the use of general AI to be a prerequisite to generative AI at an organization? So do you need to start with general AI, or can you jump right into Gen AI?
I can take that question. So I personally don't think no. So generative AI can be very useful for, like Jason was mentioning, vision AI that you're already doing or anything like that. It can really speed up the process, but it also can be its own solution. The great thing we've mentioned a couple times, this zero shot, few shot learning, is that so many of these models are already so capable, rather than having to do much training or even labeling at all. You basically just have to present the model with the right context and say, summarize this for me or answer the question based on this context. Especially for in our poll question, kind of complex data analysis and summaries, where these models kind of right out of the bat can be very quick to a solution. So no, I would say it's not a prerequisite. There are useful places where you can use generative AI in your solutions where you already have AI to speed up the process. There are also use cases where you don't even have to touch traditional methods as much to already get going with generative AI.
Cool, thank you, Tim. Another one that came in, and I'm going to add my own to this as well, is what are the common challenges or pitfalls you're encountering when implementing generative AI? And I guess I would add in, are those different across any of the GenAI platforms?
And I can take this one, Todd, really start on some of what we've seen. So I do know a common challenge or question we get, we'll go back to, is just like, how do we fine tune a model for our use case? So I think maybe just something to be aware of is a large language model can be good for some use cases off the shelf, but just be aware sometimes you do need to build a system around it. So it's not just accessing the large language model, but it's how do I set up the vector database, get the embeddings working, and how do I fit this into my workflow? So these models are very powerful in terms of what they can do. Just be aware there may be some work to figure out how does this fit into my business in the workflow. So that's one common challenge. And the other thing, I guess, kind of coming off of that is just be aware GenAI does not solve everything. So it's not good at everything. So be aware of what it's good at when you're thinking about these solutions. And just from our consulting perspective, when we think about ROI, sometimes you may have a solution where a traditional AI model may work very well. So just be open to that and realize that GenAI is good for certain use cases, and other models may be better for some others.
Great, thank you, Jason. So here's one. How do you rate the maturity and receptiveness of GenAI implementation in manufacturing versus other sectors?
I can take that. What I would say is very generically that there are multiple sectors that are implementing and adopting generative AI at a quicker pace than manufacturing. I'd say manufacturing is, I'm not saying it's not the laggard of every industry, but it's certainly not one of the leading ones, or it's moving the fastest. One thing, there's one piece of generative AI which is feeding certain sectors is there's a lot of individual adoption, where if you look at organizations that have a lot of people in marketing. The last study I saw said that over 80% of marketers had adopted generative AI in some fashion. So that could be utilizing Bard or ChatGPT to help them with their marketing. Think about sales, like if you have large sales forces, there are a lot of sales teams that are just naturally adopting solutions and leveraging the tools that are out there. And so that adoption is also accelerating internal investigation and look at how else could I use generative AI to help my business. I'd say there are certain subsegments of manufacturing that are maybe moving faster, and I'd say the ones that are maybe considered higher tech in the manufacturing have a lot of other AI already embedded into their manufacturing processes, and so it's maybe a bit more of a natural extension to add generative AI. So I think there is some differences in subsectors of manufacturing, but I would say that overall manufacturing is not what I would call the leader of the sectors. Hopefully that answers that question.
Cool. And we have another one, and this is a big one. We could probably do an entire webinar on its own, but maybe at a high level, you guys could answer investor's question from the chat regarding ethical implications, job displacement, data privacy. Like, how can companies and industry leaders, how can they balance innovation and responsible implementation of Gen AI? I know there's a lot of discourse on this right now.
I can start with the easier portion of this one, which is the data privacy, and maybe touch on the job displacement portion. But the data privacy is a scary thing with these Gen AI models, right? You've probably seen the articles about Samsung data getting leaked or something like that. Do note that those are often from the publicly accessible APIs of these models. A lot of the enterprise versions of these models coming from Google, or even like the actual enterprise versions of OpenAI's models, are what we call frozen state versions. So for like ChatGPT, it's using your responses to continue to train the model. For something like Google's Palm model, it's a frozen state. So you're accessing the model, but none of any of your interactions are going to take any, cause any changes to the model itself. It's not training based off that at all. So there's really no cross-pollination, no possibility of you asking something and someone else putting in a clever prompt to get out what you asked, assuming you're using the right models. As far as job displacement, it's obviously a very difficult question. At the end of the day, this is just another powerful tool with its own imperfections and places where it excels. You really got to think about how you want to use it, and if you're displacing jobs, maybe upskilling other employees. We were talking about this internally recently. I think Jason has a great example of how like programming used to be so much harder, and now there's more high-level programs where I can write Python way easier than someone who had to write much lower level code in the 90s. At the time, it's like, well, won't need any lower level coders. Now we just have a lot of people who can write things in Python much quicker than if they had to like interact with very difficult assembly line code or anything like that. So I don't know if anyone has anything else to touch on that, but at the end of the day, it's just another tool. Data privacy is actually not as big of a concern with the enterprise solutions.
Yeah, and Jason, I would clarify a little bit around the security on, I mean, you touched on this, but kind of the security around the different tools or the different tools available to tune enterprise models, to train them without actually training the frozen large language model itself, and why, and how, solutions like the enterprise solutions are protecting a company's data around that.
Sure, I can touch on that. And like what Tim was alluding to as well, if you look at especially the consumer-facing generative AI apps, I would just say be careful on what you accept in terms of terms and conditions and what data you put in there. Because especially a lot of those free tools, you are allowing them to use the data you put into the tool. But in the enterprise space, I would really say like all the main providers are putting a lot of effort into making sure those solutions are secure. And so kind of one of the common patterns we're seeing is that in say Google Cloud, you basically get a frozen version of that Palm 2 model, kind of that you have access to for your environment. And if you do any tuning or however you interact with that model, none of that data is going to be stored anywhere outside of your project. So basically everything is contained within your company's tenant. And my understanding is that's fairly true across all of the major cloud providers. So definitely look into the details when you're looking at the security controls and the architecture for how all those generative AI model services are provided. But in general, these enterprise-focused solutions are all trying to solve that problem for you to make sure anything that you bring of your data to that cloud environment, that it will stay there and will not be utilized for training for these large language models.
And I think the other element about that, and you can read kind of what Google has published about this and what Microsoft has published about this, but responsible AI is a big deal for their development. And so that's not just about keeping your corporate data from going in there, but it's how do they think about eliminating bias in those models and in those answers. And so that's another, there's a lot written already and available online. We're happy to send links to kind of what's been put out there around responsible AI. But I mean, that's a big deal for the big players in this. And I mean, I would assume everybody else. I mean, we're definitely familiar with what Microsoft, AWS, and Google are putting out in the subject. But I mean, it's obviously a critical issue for the industry overall. And Jason, I would suggest like maybe share a little bit about about coding and how to think of, because I mean I would say as far as job displacement, I mean there's always some friction as big technology change occurs. You think back on any of the ones that have existed in our lifetime of the internet and mobile devices and kind of all the different things that changed in the way we did business. But you know there were certainly short term where there were some people whose jobs, well, there's probably, what you're going to say with generative AI is everybody's job is going to change in some regard. Their generative AI tools are going to be available in part of most jobs that are out there, even ones that seem like they may be mostly in person and physical. A generative AI could support down the road. So I'd say like, yeah, the world is changing. The people are going to, that's going to become part of jobs that are different ways. There are some people whose jobs may not, there may be some people that are displaced, but there's going to be new jobs created. And I think it's more about jobs evolving than it is about jobs being displaced. And I think, the productivity, what people are able to achieve is going to be increased dramatically. And so what that means isn't so much that you need less people. It means you can build more, you can do more, we can create more. And I think that's really where this is going.
Yeah, and I think that echoes what we've seen historically. Is if you look decades in the past, as software and programming was kind of in its infancy, it was not terribly accessible to a lot of folks. It's very low level. It's really hard to do some small tasks. And over time, we just started building higher level languages on top of each other until we have, tools like Python that we have today. And along with that curve, the tools became more accessible, more people adopted it. And so, I think I'm sure we will see some frictional displacement. That's hard to get around with any new technology change. But, we think in the long term, if you have these new tools that are really empowering to people, one person can do a whole lot more. There's a lot more interest to the individual to get into that space. Look what I can build by myself now. That used to take a team of 100 people to do. Historically, we've actually seen more people get into, say, software development as a result of more empowerment. So I think it's definitely something to consider. Can we upskill people that we have so they're not just displaced? But we're hoping in the long term what we'll see is this is more empowering to people. We'll actually have more people jumping into spaces like software development as a result.
Yeah, and I'll just chime in. I am not an expert, but one of the things that I find super encouraging is how a lot of these models will take just natural language from people like me and give me the answers I need so that I don't need to become a programmer. So for me, it's great. One more question just slipped in here. So to what extent clean, consistent, proprietary data is a prerequisite for grounding a large language model with embeddings and vector search? So you have to have the clean, consistent data.
So I'll point out, so for certain use cases, you don't, as Jason was mentioning in his portion of our webinar, a lot of times you don't actually need to train the model at all on any new data. You just kind of need to provide it the right context to answer questions. So maybe messy data would be problematic for training a new model that's never seen anything. But these models have been trained on a huge amount of ordered and unorganized data from the internet and just anywhere you can get data, to where they're already capable of answering questions. We just need to be able to have something to latch onto in this vector search that is relevant to then be able to provide context for the model prompting. So like one thing we've noticed is you kind of have to be clever if you are going to query data where you have a huge amount of tabular data with very little text describing it. If you're going to ask a natural language question about that, you need to somehow attach some natural language understanding to that large table so that when you ask a question, we can kind of do a vector search and latch on to that description of the table on top of that and whatnot. So, and that being said, these models can handle tabular data. They can latch onto these things. We really don't necessarily need consistency. I see your word consistency there. Often with like vision models, everything needs to be trained exactly the same. Really, we just need something to latch onto with our vector search to then provide to the model as context, and then a prompt of with regards to financial analysis or with regards to manufacturing, how would you answer this question based on the context above or something like that. So I'm not sure if anyone wants to add anything else to that, but it's at least not the hugest priority to have very clean data.
And I might just note, Tim, I know I'm looked into some other approaches for not just like what's the format of the data, but looking into some additional indexing with some like named entity recognition being a common approach that we use to tag extra metadata fields to kind of like index that data. So just note there is some data cleaning and sort of like data exercise to index that data. But yeah, the nice thing about large language models is they can handle a lot of different formats of questions in text.
Great, thanks, guys. Let's. You want to wrap us up, Mike?
Yeah, again, just thank you everybody for attending. We really appreciate the time. Look, if you have follow-up questions that come on the back side of this, feel free to just email us, those and from the invite. We're happy to help. We're happy to help wherever you are on this. If you need somebody to help you kind of look into what's the right solution for your business, we're absolutely happy to help support, regardless of where you are in the cycle. From we're just getting into looking at it, trying to investigate, to we have some key use cases that we want to really build a solution around, and we can help on any of that spectrum. Thanks again. I really appreciate everybody's time. Thanks, Jason and Tim, for the great presentations, and Todd for being the moderator, and thank you, everybody else.
All right, thank you. Have a great day.
Yep. Thanks, everyone.
Thank you.